So hello and welcome everyone to our Python Foundation course. In this session today, we'll be covering the remaining operators, and the remaining operators are Bitwise Operator, Identity Operator, Membership Operator. And then if we get time, we'll also talk about decision making. And in the previous sessions, we have talked about assignment operator, comparison, arithmetic, and we have seen the data types. So without wasting much time, let's get started with Bitwise Operator. And I see somebody is asking, sir, in which organization do you work? So I'll tell you about myself. I started with the Oracle in 2017. I worked there for somewhere around 2.5 years. And after that, I moved to Anthem. And Anthem is Fortune 29 in terms of revenue. And they are in health, they are into health insurance. So they are US largest health insurance company. You can go and search about Anthem if you want. And if you want to get referred, let me know. Anthem Inc. Okay. Fine. And again, I'm a machine learning engineer, so see if few people are not on mute, or is everybody on mute? Please guys be on mute. Please mute yourself whenever you join. Okay. So when we talk about Bitwise Operator, one thing is very clear that we are talking in terms of bits. And now what are bits? Zeros and ones. I hope you remember we have talked about this previously as well. Our computer system only understands 0, 1. What is 0? Off. 1 means on. People who are from electronics, they can understand what is 0, 1. Either it's on or off. 0, 1. So that's what our computer understands, 0 and 1. But programmers and people from people who build computers, they build the entire computer on based of these zeros and ones itself. The entire computer system is a combination of zeros and ones. And that's the reason Bitwise Operator becomes very important when you talk about hardware level programming. Though from a high level programming point of view, Python, C++, you might not see relevance of Bitwise Operator. But if you talk about machine level programming, Bitwise Operator is the foundation or is the core of computer system. So there are 6 Bitwise operators that we'll be talking about. First is AND. We'll talk about this in a minute. You have OR, then you have XOR, then you have binary ones complement. Basically all your bits, let's say it is 0, 1, 1, 0, 0, 0, 0, 1. So if you do a complement of it, they all will get reversed. Then you have left shift and right shift. So let's first of all read what is AND. AND says if both the operands or both the bits on the right side and left hand side are set. By set, I mean both of them are 1. Then the output will be 1, otherwise it will be 0. And in case of OR, if one of the bit either on the right side either or on the left side is 1, then the output will be 1 or true, whatever you call it. Then for XOR, it has a very different definition, and that we'll talk about in a minute. So now let's move to the Sublime Text and discuss the Bitwise Operator. So this is your Bitwise Operator. Before starting with the AND, OR, XOR, okay, let's quickly try to understand how to convert a integral value into bits. So let's say you have 8. A equals to 8. So how do you convert it into binary? Let's see. Let's go here. Let's say this is your 8. Okay. You divide it by 2. What is your remainder? 0. And what you get out of an output? 4. Right? Then you do the same thing with 4. 4 divided by 2. It gets completely divided. You get 0. You get 2 here. Then you do same thing with 2. 2, 2. I hope all of you already know this, but I'm just doing it for the sake of completion. And now from here till here, you'll print all the values. This value 1, all the remainders 1 0 0. This is 8. Similarly, you can do the same thing for 4 as well. This is how you convert your integral value into binary. Now let's say if you do it for 4, you get 2, you divide it, you get 2, remainder is 0. Same thing you do with 2, 2, 1, 2, 0. So this is again 1 0 0. This is how you convert your integral values into binary. Now once 8 has been converted into binary, this is how it looks. And now if you want to convert this binary into integer, what you do is you do this. 2's power into 0 for first bit for this, 2's power into 1 for second bit, and for third 2's power into 2, and for fourth 2's power into 3, 2's power 3. Now what does that mean? This bit will represent 1 because this value is 1, correct? And if this is 1, let's say this was 1, so this will actually represent 1 in the final output. But if it is 0, whatever you write here, it will end up being 0. Whatever you write here, it will multiply with 0 and end result will be 0. Whatever you write here, end result will be 0. But in this case, if the bit is set, this value is 8, and 1 into 8 will give you your integral value of 8. So similarly, if you want to convert this binary into integer, you can do it orally. Okay, I'll tell you how. So by the definition that we just discussed over here, you know that this bit represents what? 1. This represents 2 because this is set, you do 2 plus 1, and this represents 4. So what will you do? 4 plus 2. So the output is 7. Is this clear? Is this conversion clear to everybody? Binary to integer, integer to binary? If it is, then let's move to the operators. Or do you guys want me to repeat this conversion? Guys, you want me to repeat this or are we good? Okay, somebody saying repeat. Okay. What about others? Yes, no, yes. You want me to repeat or shall we continue? Yes, sir, same. Okay, you want me to repeat? Okay. See, integer number, integral 8. How do you convert it into binary? Is that clear? No? Then let's repeat. Let's say you have a number 7 with you. Number 7. You divide it by 2. Okay? You'll get 3, 3, 6. What will you get as a remainder? 1. Keep a note of it. Now, whatever you received over here, now you divide this by 2. Again, you'll always divide by 2. Why you are dividing by 2? Because you have either 0 or 1. So that's why you divide it. And this is a standard process. Whatever number you get, whatever number you want to convert into binary, you will divide it by 2. Okay. And sequentially, whatever value you get as a divisor, I don't know what this is called. This is called divisor, right? Yeah. So whatever you get here, again, you will divide that by 2 and keep calculating the remainder. And at the end, let's say you get 2 here and you get 1 here. So final output is 1. So whatever you get here at the end and all the remainders, you write them sequentially from here to here. 1, 1, and then this one. This is your binary number for 7. Correct? Is it clear? Is this concept clear? Let's try for another value now. Let's try it for 11, let's say. 11. 2 divided by 11, it will give you 5. 5 2s are 10, remainder is 1. Clear. Next, take 5, whatever you get here, take this. Next, 5 divided by 2. What will you get? You will get 2. 2 will give you 4. Sorry, it will give you 4. What will you get? You will get 1. Keep a note of it. Keep a note of it. Next, 2. 2. What will you get? 1. 2 gets completely divided. Keep a note of it and start from here. Keep printing all of them. 1 0 1 1. This is 11. Okay, clear? Is this clear now? Yes, sir. Yes, perfect, perfect. Okay, guys. Now, when you want to convert this into integral, so this binary to integer, this represents 1, this represents 2, this represents 4, and I just showed you how it represents 4 and 2, or we'll discuss it again. And this bit represents 8. So 1, 2, 4, 8. Similarly, next one will be representing 16. If this bit is set, what I mean by set, if this is 1, then you do 1 into 1, you get 1, plus if this is set, 2 into 1 will give you 2. If this would have been set, then you could have done 4, but if this is, because this is 0, so 0 into 4 will give you what? 0. Now because this is set, what you get? You get 8. 8 into 1 is 8. So 8 plus 0 plus 1 plus 2 plus 1 will give you 11. Clear? And from where is this coming? This is coming from this formula. Power of 2, power 2's power 0, 2's power 1, 2's power 2, 2's power 3. Similarly, it will keep increasing. 2's power 4, 2's power 5, 6, 7, 8, 9, 10, depending upon the bits. Okay. Is it clear now? Or do you want me to repeat any specific part? Yes, sir. Clear? By yes, sir, do you mean it's clear? If it's clear, write clear. Okay. That helps helps me in understanding it is clear. Yes, sir. Clear, sir. Okay, clear. Perfect. Okay, got it. Cool, guys. Let's move to the next thing. So I think this is a very easy thing to remember. If you see 3 bits, okay, this represents 1. This one represents 2. This represents 4. So these, because these two are 0, this is 4. Simple. So now just by seeing a binary value, you can tell its integral value very easily. Same otherwise as well. You know what? It is 7. So 7 will be what? 1, 2, 4. If you're not able to convert it very quickly, over a period of time, you will get to you will get habituated with this. Now let's come to XOR. So what is XOR? Okay, everybody is on mute. What is XOR? XOR operator says if both the bits are of same type. XOR operator, okay? This is the symbol of XOR. If both the bits are of same type, then the output is 0, otherwise it is 1. Clear? Simple. You just have to remember this. If both are 0, output is 0. If both are 1, output is 0. Basically, the idea is if both the bits are of same type, then the output is 0. If they are of different type, the output is 1. As simple as it is. Okay. So let's see by an example. What is A? A is 8. What is B? B is 4. So what will you get as an output? You will get 12. How? 1 0 0 will give you 0, 0 0 will give you 0, 0 1 will give you 1, 1 0 will give you 1. And if you convert this integral binary into integer, what will you get? This is 0, this is 1, this was representing 2, this will represent 4, and this will represent 8. So 8 plus 4, 12. Clear? Clear to everybody? It's simple. Okay. If this is clear, clear, sir. Okay, please, sir. Next is OR. So in case of OR, what happens? In case of OR, if both are 0, let's say in this case, both are 0, only in that case you will get a 0. Otherwise, if one is false, even if one is true, okay, either left operand or right operand, then the output will be true. True means 1. Clear? I think this is simple. In case of AND, it is opposite. If both are true, only then you will get a true. If either one of the operand is false, you will get a false. Because AND means both of them should be true. And first and second, both are true, only then you will get a true. Otherwise, it will be a false. Okay. Now, this is if this is done, there are two important ones. Those are left shift and right shift. What is left shift? As the name suggests, it is shifting something towards left hand side. Right shift, it is shifting something to the right hand side, but right now we don't know what is that something. Let's try and understand in detail. So I hope a lot of you might have seen or read 64-bit computer or operating system, 32-bit operating system, and Raspberry Pi is a 8-bit system. You guys have heard about this? If you go to properties of your computer, you'll see your operating system is a 32-bit operating system or a 64-bit operating system, correct? Now, what does that mean? That means your operating system can represent or is representing all the characters in 64 bits form or in 32-bit format. That's what it mean. So let's say when you want to represent A, you remember its ASCII value was 97, and your computer will represent 97 on 32 bits. It will have 32 bits. Let's say it's a 32-bit operating system. So it will have 32 bits like this. And on these 32 bits, it will try to represent 97. And this is just for an example. Let's say in our case, A is what? A is 8, right? A is 8. So in our case, the A was 8. So don't worry, guys. Don't take it as it is. I know there might not be 32 values over here, but the idea here is to just to make you understand. Okay, consider that there are 32 zeros over here, 32 bits. So overall 32 bits are there. So this is how your 8 will be represented. 1, 2, 4, 8, yeah, in your memory. Now, when you say left shift, apply left shift of 2 bits. Okay, on A, apply left shift of 2 bits and tell me what will be the answer. Apply left shift by 2 bits on A. What will be the answer? Answer will be 32. How? What we do is we pick this copy, we copy it. Oh, sorry. We pick this value and shift it by 2 bits. What do you mean by shifting it by 2 bits? You'll copy it and you'll paste it here. 2 bits, okay? And this starts to look like this. Making sense? I shifted it towards left. And now if you see 1, 2, 4, 8, 16, 32. This is representing 32, and that is what your answer is. Clear? Is this understanding clear? If you want to see it via formula, it says, it means like this: A multiply power of 2 into number of bits. So let's say if A left shift by 2, then this is the formula. What will happen? 8 multiply by power of 2 power 2. What 2's power 2? You'll get 4. 8 into 4 is 32. Correct? Clear, everybody? I want to hear from everybody. You just have to write clear. And if it is not, you can write not clear. Please repeat. If it is clear, that's fine. You don't have to write. I'm fine with that. But if it is not, guys, please write it down, okay? Because it's very important for you to understand this. Okay, if this is clear, let's move to right shift. Now, what will happen in case of right shift? Let's remove this now. This is our 4. Now, in case of right shift, we have B. We are taking B. We can take A as well, but yeah, we are just taking 4. Okay. So this is your 4. This is how 4 will be represented. Now you want to shift it towards right hand side by how many bits? By 2 bits. By 2 bits, shift this whole thing, copy this and shift it towards right hand side. Shift this entire thing towards right hand side. So you'll shift it here. Now when you shift it here, what happens? This goes away, this goes away. Correct? Basically, you have to copy this and shift it towards right hand side. So what happens? You take this one, shift it here. What you get as an output? You get 1 as an output because this represents 1. Clear? This is again same, right side, left shift. And if you see it by formula, now B, instead of multiply, it will be divide. Divide power of 2's power number of bits. So what is 2's power 2? 2's power 2 is 4. So 4 by 4 is 1. Simple. Clear? Is it clear to everybody? Is bitwise operator clear? Okay, repeat once. You want me to repeat left shift or right shift? Haha, good. So somebody is saying, sir, what happens if I do 4 right shift 4? You'll get 0. Okay, because it's not gonna go any further. And if you want to try it out, let's try it out right away. Code chef ID. Let's open it. Guys who haven't downloaded any IED, they can directly go on code chef ID and try this out. Okay, just go here, select the Python language, whichever you want to use, and let's do print 4 2. Okay, and let's execute this. Let's see what we get. We get 1 as an output. Now you do 3 over here. What will you get? You will get 0. Clear? Now you keep shifting as many numbers you want, but you will get 0 only because there's nothing else to be shifted, right? Clear? You cannot shift anything else if you do it, if you shift it more. And if you want to see it by formula, let's try to see it by formula as well. So this is the formula, right? For right shift. Same thing happens in right shift as we did in left shift. The only thing that changes is the direction. In case of right shift, we shift it towards the right hand side. In case of left shift, we copy the set values. Okay, or you can say we copy this entire thing towards right hand side, entire thing towards left hand side, assuming everything is 0 over here. Okay, everything is 0 over here. And if you want to move this to the left hand side, what happens? Copy, and you want to move it to the left hand side. It starts to look like this. Everything was 0. You want to move it to the right hand side, so you'll copy this, okay, and paste it here. What happens? These two will go away, right? Because it's beyond the limit. This is how it looks. So this becomes your left shift by 2 bits. This is your neutral or the original, and this was your right shift by 2 bits. And via formula, if you want to see actual value into power 2's power as many number of bits you have. In our case, they were 2 bits, so this value becomes 2, but you can replace it with your value. Let's say here also we had a, so a divide by power 2 bits, whatever bit you want to shift it with. Clear? Let's say you write 4 here, then what will happen? 2's power 4 is 16. So if you try to divide 8 by 16, what will you get? You'll get 0, right? In terms of integer, though it will be 0.5, but if we talk in terms of integer, you will get 0. So that's why you get an output of 0 in this case. Let's say if we even do it like this. Zero. Okay. So in left shift, we got output 0 as very less chances for right shift. It's a little bit confusing, sir. Okay. Fine. Let me help you understand it real quick. See, this was your original representation. Clear? If you want to shift by 2 bytes, shift A left hand side by 2 bits, shift A. So let's see what this means, how this represents. Okay, how do we represent, or how do we apply this operator? A left shift 3 bits. You want to shift A by 3 bits. So let's say this was your original A. Okay, this was your original A. Now you want to shift this original A towards left hand side because it's a left shift operator, and by how many bits? By 3 bits. So what does that mean? By 3 bits. By 3 bits. So 3 bits will 3 more bits will be added. Basically, that's the idea. Okay, or it's just way of thinking, guys. The idea is I somehow want to shift this entire piece towards the left hand side. If I want to move it left hand side, it starts to look like this. And if I represent it properly, it becomes like this. So now if you see, 3 were added, and if you try to decipher this representation, it looks like this. And if you try to find the value for it, this represents 1, this represents 2, 4, 8, 16, 32, and 64. Correct? And this is what your output is. Is it making sense now? Deepthi? Lokesh? Others? Is left shift okay? Are you guys able to understand left shift? Yes or no? Perfect. If you have understood left shift, let's remove this. In right shift, you just have to do the opposite. Right now we are moving it to the left hand side, right? Now we'll move it to the right hand side, and when we move it to the right hand side, your extra values or extra zeros, whatever you had on the right hand side, will get removed. Let's say this was, what was this? This was 8, right? This was 8. Let's get rid of this now, all these extra values. Now my original value was 8, and I want to apply on 8, I want to apply right shift by 3 bit. This is my problem. If I try to solve it via formula, it will be 8 divided by power of 2, 3. That means 8, this equals to 8 divided by 8, which gives us output of 1. Simple. By formula, you can do it really easy. Now, if you want to shift it towards right, this entire thing needs to be shifted towards right hand side. Copy it, move it towards right hand side. So now if you see these 3 values, either if it was 0, if it was 1, whatever it was, these 3 bits will go away. You remove them. That's it. Simple. And whatever you get is your output. What do you get as an output now? 1. And that's your output. Is right shift clear now? Is it clear? Yes or no? How to get 0 output in left shift, sir? See, how will you get 0 output in left shift? You cannot, because you are doing a multiplication. If you even see via formula, you cannot get it, right? You cannot get a 0 output in case of left shift because you're shifting it towards the left hand side, and over there the value will only increase. It will not decrease. If you want to decrease it, you will have to get the right shift. I know this is a little tricky for those of you who are seeing it for the first time, but if you still have any questions, do let me know. Is it clear to everybody? Perfect, perfect. And I'll give you a pro tip to remember what is a left shift and right shift. Okay, so right shift, if you see, this is how you apply right shift: 4, right shift, and 2. So you can think it like this: right shift is saying this value is greater. this left hand side operator is greater, I'll reduce it. And that's why right shift is something that will do a division. Or by this representation also you can memorize what is a right shift. Right shift will shift the bits towards right hand side, and that many number of bits will be removed. As a result, my value will decrease in case of right shift. In case of left shift, it says my operand on the left hand side is smaller, let's make it bigger by multiplying something to it. Or you can think it from, or you can remember it from this representation where it says if I want to move something to the left hand side, its value will increase. That means I'll have to do a multiplication. Clear? This is how you can remember left shift and right shift. Any questions, anybody? If it's clear, let's move to the remaining two operators, that are membership operator and identity operator. Shall we move towards these two? Shall we talk about them? Or you still have any questions? Let's move. Cool. Good. So what is membership operator? Membership operator says evaluate. So there are two ways to represent. There are two membership operators, in and not in. So they are opposite to each other. In, not in. In says evaluates to true if it finds a variable in the specified sequence and false otherwise. So basically you will be given a sequence and you will be given a variable, or you will be given a value. If that value is available in the given sequence, then the output is true, otherwise it is false. Okay, so let's take an example. So there are two sequences that we'll check upon. First is Python, and then you have a list. Okay, so, and this is my value 2 in L. What is L? L is my list. Is 2 part of this list? If it is, output will be true. If it is not, then the output will be false. So let's see what the output will be. If we execute this, the output is, let's forget this for now. The output is true. Why? Because 2 is part of this list. Here you have to. That's why you get a true. And what is not in? Not in says if this is not part of L, then the output will be true. Otherwise, output will be false. If this was part of L, then the output would have been false in case of not in. Basically, not in is exactly opposite of in. Is it clear to everybody? This is really simple, but an important one. When we'll talk about loops now, at that time, this operator is being used. This membership operator will be used in case of loops, for loop. Because in case of Python, for loop is little different as compared to for loop of your C++. Clear? Any questions, anybody? Is in, not in clear? Yes, no, yes. Okay, as I see, no, yeah, it's clear. Good. I hope it's clear to everybody. Now, next is identity operator. What does this operator says? This operator says if the two variables are pointing to the same memory location, then the output will be true, otherwise it will be false. So let me show you via diagram. What does this mean? And here we can read it once. Evaluate to true if the variable on either side of the operator point to the same object, and false otherwise. Basically, same object means to same memory location. Let me show you by an example. So let's say this is my memory point, where memory location where 8 is stored, and this is its big address. People who have attended our previous classes, they know what this address is. And this is my house address, or this is my actual address. This is how I know where A is. A is equal to 8. 8 is stored in the memory. Now what it is saying is, if let's say C, another variable, if that C also points to the same memory location or to the same object, then A is C will give me true, otherwise it will be false. And how do we verify this? We verify this using a ID operator. There's one operator called ID operator. Oh, sorry, not operator, a function. It's a function, ID function. What this function does, it gives us the memory location of C and A or any variable. So when we execute this, it shows us the memory location. So if you see, these memory locations are same. Memory location of A and C, it's exactly same. And that's why you get true. But if you do sum underscore D is A and you try to find out the memory location of A, you'll see the output is false because they are not pointing to the same memory address, and you can easily see the memory address is different. Clear? Is this operator clear? Identity operator is yes or no? If it is, we can move to decision making. Clear? Okay guys, goody good. Then I'm closing this. I have covered all the operators, and if you have any doubt, please ask. Otherwise, we'll move to decision making. No doubt? Good. Let's move to decision making. So next is decision making. Let's try to understand what is decision making quickly. So it says decision making is anticipation of conditions occurring while execution of the program and specifying action taken according to the condition. Basically, it means if you want to make your program intelligent and want them to take their own decision based on certain predefined conditions. Let's say if you get 90% marks in exam, you'll get A plus. If you get more than 80 but less than 90, you'll get A. So if you add these conditions to your program using decision making, then your program will be able to assign grades automatically based on your marks. So similarly, if you want to add more dynamic functionality to your program, you can use decision making. And what is decision making? There is a keyword called if, else, elif that are used by Python to enable decision making in your Python program. Okay, so one very important thing to note here is all the conditions should return either true or false, because based on the condition, if the condition is true, then the certain lines will get executed. If the condition is false, then those lines won't get executed. Okay, so decision structures evaluate multiple expressions which produce either true or false as an outcome. We need to determine which action to take and which statement to execute if outcome is true or false otherwise. So let's try to understand using this flow diagram. You come from here, you check the condition. If it is true, you execute the code. If it is false, you exit. So this is if. If is your keyword that you use for decision making. If, write a condition, and this condition should return true or false. If it is true, this code will execute. If it is false, then nothing happens. This code doesn't execute. We go to the next statement after this. Is this clear to everybody? It's very simple, I know, but just to make sure it's clear to everybody. If it is, then we'll move to some examples and we'll move to next. If else. Let's say if your condition is not true, then move to else part. Whatever is written in the else, execute it directly, blindly. Just don't see what's there. You don't have to check any condition in case of else. If this is false, if whatever you have written over here, if this is false, execute the else part of the code automatically. And this is how the flow diagram looks like. Even in your exams, you can draw these flow diagrams. This gives a very clear understanding to your examiner as well, that you know the concept. Condition, if it is true, run the if code. If it is false, run the else code and exit. Okay. Next is nested if, elif, else. But before coming to this, let's see some examples of if and else. So let's say you had m equal to 60 and you said if m is greater than 50 and less than 80, and then print toffee. Okay. Give me a second, guys. Let me comment this. Is this clear? Is this simple statement clear to you? Toffee gets printed. But let's say if this was 70. Nothing gets printed. Nothing. Why? Because this condition is not true. But let's say if we enhance our code to a next level and we add a little more functionality to it, and that functionality says if this is not true, then don't worry, you add a else part to it and you can print whatever you want to print. So in this case, what happened? It says, oh, m is not defined, my bad, sorry. Let's define m. Okay, so in this case, if this is not true, correct, because it's m is not greater than 70 and less than 80, right? This is not true. So no problem. We'll go to the else part. So if else, without even checking a condition, we'll print this. Let's say if this was 100, even then this will print this. But let's say if this was 85, or not 85, actually 75, then this will not get printed, only this will get printed, and we'll move on. We won't print this because this is else. This only gets triggered if this is false. That's why it is called if else. If this is true, then good, otherwise go here. If this is true, then fine, we don't have to care about this, we don't care about else. Is this clear? If this is clear, only then I'll move to Alif, because otherwise you'll get little confused. So if this is clear, crystal clear, then we'll move to the next concept. Okay, good guys, good. Okay, if this is clear, this is the same thing, no point of talking about this. Now let's move to if, elif, else condition. Okay, so somebody is saying, sir, if m equals to 60, then it'll be less than 80, na sir. Then it is less than 80, na sir. Oh, good. I was waiting for this. Goody good. So somebody is saying, sir, if m is 60, this one, then it is less than 80, na? Correct. That's why you have AND operator in between. This is true. Okay. First is false, and then this is true. What will be the final output? True and false. What will be the final output? True and false. It will be false because you have AND in between. Correct? But let's say, to answer your question, let's make that change over here. If this was OR, then what will happen? Then what happens is, oh, let's comment this. then what happens? It returns you toffee. Why? Because either one of this should be true to get this final output as true. This entire condition should be either true or false. In this case, it's becoming false because both of them should be true to get the output as true. Making sense? In this case, first is false, and then you have a or operator, and this is true. And the final output will be what? It will be true. Why? Because you have a or operator in between. Or says either this should be true or this should be true. If any one of these is true, then the output will be true. And that's why toffee gets printed. Clear? Lokesh, it's clear? Perfect. Perfect. Good that you asked that question. I'm really happy. Guys, same as what Lokesh did. He was not clear with something. He asked a question. I would urge you all to ask questions if you are also not clear on something. Okay? That will really help you. Because to me, I know these concepts, and people who are able to understand, they already know it. So you are at a loss. Don't hesitate. Don't think my question could be a silly one. People will make fun of me. No, nobody cares. Okay? Nobody cares. So please ask if you are not able to understand something. Good. Okay. Next is if, Alif, else. This is little important. Just try and understand it properly. So Elif, Elif means else if. Elif represents else if. Okay, this is first. Now, as this says else if my first condition, if this condition of mine is not true, only then I'll come here. Only then I'll come here. Why? Because it says else if. Else means if this was not true. If my if was not true, only then I'll check for this condition. Otherwise, I don't care. So that's why you see good boy is getting printed when var equals to 400. But let's say if this was 410, then good girl gets printed. Why? Because this is false now. Now this became false. If this is false, only then I'll come here and check. And if this becomes true, I'll print this. I don't care about the next one. Why? Because that is else. If nothing is true, then I'll come here. So because my else if was able to find a match, we print good girl. Let's say now this was also 220. Now in that case, we'll have to go and print bad because neither this was true nor this was true. We had to print bad because we were in else statement. Clear? Is it clear, guys? Yes or no? Clear. Goody good. Goody good. Now I'll write a question for all of you and you will have to solve it. Okay. We are almost above time, but I started 5 minutes late. We were discussing about something else. So I'll give you a question. Let's see how many of you are able to answer that correctly. Let me take this one only. Let me modify it a little bit. No, it doesn't make sense. Good. Let's print good. Okay. This is good. 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 Okay. So tell me what will be the output in this case. What will get printed on the screen? No, guys, just have a look at the question once again properly. Just go through it. Whosoever has answered till now, I must tell you the answer is incorrect. Just please revisit, just review it once again and answer in one line itself. Okay, don't answer it twice because then it will get difficult for me to track. Again, this is a hint. You'll get 2 outputs. For those of you who are just writing one output, that is wrong. You'll get 2 outputs.
Goodbye and good day.
That's good. Yeah, but please don't unmute yourself. Yeah, that was good. Yes, now people have started writing the correct answer. Yes. So this is tricky. Okay, please make sure that you understand it properly. The examples that I took were easy. Okay, but don't get fooled. Now let's say if we have this. Then what's the output? What will be the output? In this case, what will be the output? Yes. No, Deepti. Correct. Pradesh. Correct. Lokesh. Nope. Ritesh yours is correct. Yes. Yujvendra yours is also correct. Vishnu. Vishnu no. So the output will be bad boy and good. Because this is separate and this is separate now. Why? If this is true, then this is fine. Otherwise, print from else. Next, the next if else letter starts. If this is true, fine. If this is not true, we'll go here and print this. So that's why good boy and good gets printed. Okay. Okay, guys. Goody good. That's it for this session. And with this, we cover our decision making as well. In next session, we'll start with loops. Python has 2 loops, while loop and for loop. We'll cover them and then do some questions as well along about loops. Okay. So see you in the next session.